Hello, pre-algebra. You and me are going to talk about Chapter 10, Lesson 9, Volume of Pyramids, Cones, and Spheres. Unfortunately, there's no real easy way to remember these formulas, so you're just going to have to memorize them. Memorize them, write them down, get used to them. This is also currently the last video of the 2013-2014 school year, so enjoy, little party, woo, throw your fingers up, little party. Alright, so volume of a cone and a pyramid has the same formula. The only thing is that a cone and a pyramid have two different bases. Cone has a circular base and a pyramid has a polygonal base. So, to figure out the volume of a cone, you're going to do 1/3 base times height. And when I say base, it means big B, which is the area of the base. So remember, the big B means area of base. So if it's a circular cone, or just a cone, the area of the base would be pi r squared. Now, if we have a square pyramid, the area of the base would be the side times the side. So just remember, it's 1/3 times the area of the base times the height. And also, notice how height here does not mean the slant height. It means the actual height of the pyramid, from the top of the pyramid to the bottom of the pyramid. Before, we'd been talking about height as the slant height, which is the distance from the vertex to the base along the edge, along lateral face. Now that we're talking about volume, it's actually from the very tip of to the very bottom of it. It goes straight down. It doesn't go along the lateral face like slant height does. Okay, so we're going to find the volume of a square pyramid that has a side of 5 feet by 5 feet and a height of 20 feet. And we know both sides are the same because it's a square. All right, so if you remember our formula, it is 1/3 times the base times the height, and the base is actually the area of the base. So if I replace that with 5 times 5, which is the area of the base, and the height with 20 feet, and just remember that the base is feet and feet, and you multiply it all together, we are going to get the volume, which is 166.7 feet cubed, because we're dealing with volume, and we have 3 feet being multiplied together, so feet times feet times feet is feet cubed. All right, now let's do this with, there you go, and again, this was rounding, so it's approximately 166.7 feet cubed. All right, now let's deal with a cone. Well, the cone has a height of 5 centimeters and a base radius of 3 centimeters. So how do we do this? Well, we're going to be 1/3 times the base area times the height. Well, the base area is pi r squared. The height is 5 centimeters. So let's figure out the area of the base. And we're going to multiply by the height and by 1/3. And that's going to give us approximately 20.93 centimeters cubed. And it's approximate because I rounded, and you can tell I rounded because I have the line over the 3, but also because I used pi. So there we go. This answer is approximate, hence with the little wiggly lines. All right, now let's talk about the volume of a sphere. Notice the 3. Notice that highlighted 3, and I'll make it more apparent for you. Notice the highlighted 3 right there, right there, right? The highlighted 3. So this is the third power. A lot of calculators, unless you're using scientific calculators, don't have a button. Actually, not even then. I've never seen a button to the third power that allows you to do the third power. Specifically, now there's a button that does allow you to do to any power, and that's the little caret button, but it's usually only on scientific buttons, and it looks like this. It's just a little like upwards. It's called a caret. It's called a caret. I don't think it's spelled like, hey, that's a vegetable carrot. Anyway, so make sure you use it, or if nothing else, you can just do the radius 3 times. That would be radius times radius times radius. And it's más importante. I even pulled out the Spanish for you guys. So radius cubed, or radius to the third power, is the same thing as radius times radius times radius. 3 radiuses, radii, all multiplied together. All right, so let's go ahead and use this. And let's do it 2 different ways. We're going to figure out the volume of a sphere to the nearest whole number, or the nearest whole number. We're going to use 3.14 for pi. We're going to write our answers in approximation because we've already approximated pi, and we need to remember our units. And remember, our units for volume are units cubed. All right, so we have a sphere with a radius of 15 meters. So I'm going to plug that in from my radius, which is 4/3 times pi times r cubed. Well, that would be 15 cubed, which is 3,375 meters cubed, because we also cubed our units, which in this case are meters, and we're going to multiply by pi, and we're going to multiply by 4 over 3, and we're going to get 14,130 meters cubed. And I actually didn't have to round that one for my approximation, even though it is already approximate because we're using 3.14 for pi. This one I didn't actually have to round. It came out to that nice whole number for me already. Okay, now if we have a sphere that has a diameter of 7 meters, we need radius for our formula. Well, the cool thing is the diameter, oh, that's rounded because of pi. All right, the diameter is 2 times the radius. So if we divide both sides by 2, we figure out that the diameter divided by 2 gives us a radius. So a radius of the sphere that is 7 miles is actually 3.5 miles. So we're now going to plug it into our formula, and we're going to cube 3.5. That's going to give us 42.875, and then we're going to multiply by pi, and we're going to multiply by 4/3, and we're going to get 179.5, but since we need to round to the nearest whole number, that's 180 meters cubed, or 180 miles cubed. That's the volume of that sphere. Now, why you would want to make a sphere that is 7 miles in diameter, I don't know. That would be like having something, you know, like 15th the size of our moon, which is huge. Anyway, so yeah. Anyway, it's just an example. Bye, guys. Last video. Yay, little party.